everyone. In the last class we have discussed about the first equation of motion. So today we are moving to the second equation of motion. The second equation of motion we also called it as position time relation. Okay. So look here, from the velocity time graph, a small portion is taken from it. Okay, from the velocity time graph we have taken a small portion from it. That is PQRS. Okay, here PQRS is a trapezium. Okay, so we want to find the area of it. Okay, I told you that in the earlier classes, area under velocity time graph is displacement. Okay, once more I will say, area under velocity time graph is displacement. Okay, so with the help of this T1 and T2, T1 and T2, we can easily find out its area. Okay, then we will get the displacement. Once again I will say, with the help of T1 and T2, we can easily find out its area. Then we will get the displacement. Okay, then how can we find the displacement from it? To find the displacement from this S to R. So for finding the displacement from S to R, it is enough to find the area of the quadrilateral PQRS. Okay, once more I will say, to find the displacement from this S to R, it is enough to find the area of the quadrilateral PQRS. Okay, look here you can see the quadrilateral PQRS. Okay, here I mentioned T1, here I mentioned T2. Okay, in between this SR you can see H. Okay, in between P and S you can see A. In between Q and R you can see what? B. Okay, so I told you that quadrilateral PQRS is a trapezium. This quadrilateral PQRS is a trapezium. Okay, do you know the equation to find the area of trapezium? Do you know what is the equation for finding the area of trapezium? That is half H into A plus B. Okay, for finding the area of trapezium, we have an equation, that is half into H into A plus B. Okay, here H you can see and B also you can see here. Okay, then here A and B, here this A and B are the length parallel to sides. Okay, here A and B are the length that is parallel to the sides. Okay, then H is the distance between them. Here H is the distance in between them. Okay, so you can easily understood by looking this figure. Okay, then from T1 to T2 the displacement is equal to area of trapezium PQRS. Once again I will say, from here T1 to this T2, the displacement is equal to area of trapezium PQRS. So here you can see this H is lying in between the S and R. Okay, here the length A is lying in between P and S. Then here B is lying in between Q and R. So we can write from T1 to T2 the displacement is equal to area of trapezium PQRS. Okay, so we can write half SR. That is H is lying in between this SR. Okay, so we can write half H, instead of H we can write here SR. Okay, then what we will write instead of B, A and B? Here A is PS. Okay, here B is QR. Okay, is it clear? So we can write area of the displacement is equal to half into H, that is SR, half into SR into A plus B, that is PS plus QR. Is it clear? PS plus QR. Okay, so here T1 is the initial velocity and T2 is the final velocity. Okay, so we can write PS is equal to u, that is initial velocity. Then qr is the final velocity. We can write as v. Okay, so here h is lying in between sr. Okay, is it clear? So we can write, we can substitute this ps is equal to u and qr is equal to v and sr is equal to t. I write this t1 and t2 I take as t. Okay, so we can apply this value to the equation. Then we can write displacement is equal to here sr is t. Okay, so I am going to apply this equation into this. Okay, sorry, I am going to apply these values into this. So half into sr, that is t, into ps, that is u, qr, that is v. Okay, we get like this. Displacement is equal to half t into u plus v. Okay, is it clear? So half t, I am writing this u here. We all know that from first equation of motion we will get v is equal to u plus at. Okay, from first equation of motion we will get v is equal to u plus at. So I am applying this into this here. Okay, so I am writing v is equal to u plus at. Okay, is it clear how I get this? Then next step, half t into, here you can see u plus u, consider this as 2u plus at. Okay, then we can multiply this, that is half t into 2u plus half t into 80. Okay, half t into 80. Okay, is it clear? So this will multiply, then u plus half at square. Okay, we will get u plus half at square. Is it clear? So here t is there. Okay, sorry, here t is there, I put here. So SC is equal to ut plus half at square. Okay, is it clear how we will get this? How I get this? So this is the second equation of motion. So the second equation of motion we also call it as position time relation. So the first equation of motion, that is v is equal to u plus at. Then the second equation of motion, that is v for finding the displacement, we derived this. We will get SC is equal to ut plus half at square. Is it clear? We are moving to the third equation. Okay, that is the third equation we also call it as position velocity relation. Okay, once again I will say the third equation we also call it as position velocity relation. In the second equation I told you that displacement is equal to the area of quadrilateral or area of trapezium PQRS. So I write this as the displacement is equal to half t into u plus v. Okay, so instead of writing this displacement, I am representing it by using capital letter S. Okay, S is equal to half t into u plus v. That is displacement is equal to area of trapezium PQRS. Okay, so we all know that acceleration is equal to v minus u by t. We all know that acceleration is equal to v minus u by t. Here v is the final velocity and u is the initial velocity and t is the time taken. Okay, so put this equation as 1. Okay, put this equation as I am rewriting this equation as t is equal to v minus u by a. Okay, I am rewriting this equation as t is equal to v minus u by a. Okay, so put this equation as 2. Okay, put this equation t is equal to v minus u by a as equation 2. So I am going to substitute equation 2 in 1. Okay, substituting equation 2 in 1. Then how will we write? How we can write? I substituted this equation 2 in 1. Okay, so as in the place of t, we can substitute v minus u by a. Okay, look here. So I am going to substitute half. Instead of this t, we are substituting v minus u by a here. Okay, that is v minus u by a. Then this u plus v into u plus v. Okay, is it clear how I got this? I substituted this equation 2 in 1, then I will get like this. Then I get like this, half into v minus u by a into u plus v. Okay, we can write this equation like this, half into v minus u into v plus u by a. I just rearrange this equation into this. Okay, like this. Okay, so you all know that a minus b into a plus b is equal to a square minus b square. Once again I will say a minus b into a plus b is equal to a square minus b square. So I am substituting. We can write as half into v square minus u square by a. Okay, so I told you that v minus u into v plus u we can write as v square minus u square. Okay, in earlier classes you have studied that a minus b into a plus b is equal to a square minus b square. So I write like this like this. Okay, that is v minus u into v plus u as v square minus u square. Okay, by a, half into v square minus u square by a. Okay, so we can put this two term, we can put this two term into this side. Okay, once more I will say we can put these two terms into this side. So we can write this like this, 2as is equal to v square minus u square. Okay, then we want to rearrange this. V square is equal to u square plus 2as. Okay, this is the third equation of motion. We will get this equation as the third equation of motion. So this equation is also known as position velocity relation. Okay, so v square is equal to u square plus 2as is the third equation of motion. Okay, the equation helps us to calculate final velocity of an object using u, v and s. Okay, once again I will say this equation helps us to calculate the final velocity of an object using u and s. Okay, even if time taken is not mentioned. Okay, so we can easily find out with the help of this equation. Is it clear? This third equation only applicable to uniformly accelerated motion. Is it clear? So from today's class we have studied about the second equation of motion and the third equation of motion. So these are about our second chapter. Next class we want to do some problems by connecting with these equations. Okay, thank you.